Okay, obscure fact. Skating is possible only because compressed ice melts. So skaters glide on slippery water, not on slippery ice.
So now, are you saying the pressure
Yes.
between the blade and the ice
Yes.
is melting the ice
Yes.
so that there is an ever so thin layer of water
Yes.
that the skater is actually gliding?
Generally, people's understanding of the word force is accurate to how we use it in physics.
Okay.
It's generally the same.
Okay.
Okay? I need more force to open this door. Okay? So you put in a force. There's another term called pressure, which is less familiar as a physics term in the public. Okay? So pressure is force divided by the area over which the force is operating. So watch what happens. If I have a knife and it's not cutting because it's dull, I'm putting a force on that knife and it's not working.
Right.
You have to ask yourself, what is the area of the cutting blade? What is the area of the thing that's touching the thing you're trying to cut? It's dull. So it's not very big. Let's say it's 1 square millimeter over the entire length of the blade, let's say.
Okay.
Okay? Now you sharpen the blade. What does that mean? You're reducing the surface area of the cutting edge.
Right.
Now it's 1/100th of a square millimeter. Because that stuff you can't even, and now the force divided by the area creates an enormous pressure.
Right.
So the lower the pressure, the lower the area is of that cutting blade, the higher the
pressure.
The pressure is for the same force that you're using to cut. That's why sharp knives cut. That's what it means when you sharpen a knife. You're shrinking the denominator of that equation. Pressure equals force divided by area. So if you've ever ice skated, I used to be a skating guard, actually, long ago. So when they, quote, sharpen skates, what you do is you actually put a concave cut. The bottom of the blade is concave.
That's right.
Okay, I don't know if you ever look closely at this.
I haven't. So every day's a school day.
Okay, go every day's school day. So it's concave, the full length of the blade. So that means if you lean to the left or to the right, all of your weight is on basically a knife edge of the skate. And so that creates extreme pressure on the ice. And how thick is the ice? It's like a fraction of an inch. Did you know this?
Okay.
Ice skating rinks, it's like a fraction of an inch.
Didn't know that.
Okay? So now you put pressure on the top of that ice, and it melts the ice in the instant your skate comes over it. That is one of the most profound facts in the universe. The sharper the edge, the higher the pressure.
Right.
Okay, you got that. All right. So now, we all know that ice floats.
Okay.
That is rare among among substances. Usually, if you freeze something, cool it and freeze it, it gets smaller, right?
Right.
But
Okay. Water, however, when it gets to about 4 degrees Celsius, by the way, water is shrinking down to about 4 degrees Celsius, not freezing yet. Freezing would be 0.
Right.
4 degrees Celsius. Then it says, I'm now going to get bigger.
Right.
So between 4 and 0,
Right.
it becomes puffier. And it becomes less dense than the water it's sitting on, and it floats. Okay? That's why it is almost impossible to completely freeze a lake in the winter. Because if a chunk of ice forms anywhere, it floats. And you will freeze the top of your lake. And that will insulate the rest of the lake from the cold temperatures that are above it.
Right.
Basically prevents the bottom. So all the fish just get lower and lower and lower, and they hang out until springtime, and then they come back.
Right.
Otherwise, we would be killing all life forms in every lake for every winter. Okay? So now, watch what happens. Now, I now have this ice cube that is bigger in volume than what it's melted, than what it would be melted. Okay?
Right.
With you.
I want to now squeeze that ice cube. That's not allowed. You can't do that. Because the ice has to be that volume.
Got it. That's it.
Right.
It has to be that volume to be ice.
So it has to return
Yes.
to the state before you froze it.
Yes.
Which means that it's got to turn back to
It's
water.
got to turn back to water under pressure. This is also why pipes break in the winter.
Right.
What happens is water is sitting there, okay? So the water tries to expand, but the pipe is preventing it.
Right.
Okay? So you can get down to 31 degrees. No, nobody's pipes freeze at 31 degrees
Right.
or 30 degrees.
Right.
You know, the water is still there contained, okay? Then you reach a point where the pressure of the pipe can't keep this thing as water,
Right.
and the water changing state becomes more powerful than the copper pipe itself.
That's right.
And it says, I am now Iceman.
Right.
It busts out of the pipe and it'll break practically anything. But if you make something that's kind of unbreakable, it'll stay water all the way down. You could take a grid, like a screen that would be on a screen door, but just to make this a little more interesting,
Right.
Increase the size of the screen hole.
Right.
Make it like maybe a half a centimeter on a side, and hold it horizontally. Take a block of ice and place it on this screen. And it's got to be really heavy ice, and the screen is not too fine a grid. So what will happen is the ice in contact with the screen will feel the weight of the entire block, and it's going to melt it.
Right.
So it melts it, but just to get around the screen.
Right.
And it comes out on the other side. I am melted ice at 31 degrees because I was under pressure, but now I'm back to 32 degrees. I mean, 30, did I say that right? It melts in a below freezing temperature. And when it comes out the other side, it just freezes again because it's no longer under pressure.
under pressure.
So you come back in a half hour, half of the block has passed through the screen.
But it's still ice on the other side.
Still ice on the other side.